Thanks. So I'll be talking about algorithmic rural road planning in India, constrained capacities and choices in public sector. I'm Harsh. I'll be representing the work which has been done by 6 other people within the Indian government. So the site and the context of the work, the site is the Ministry of Rural Development, which is the federal department in charge of rural development related activities in the government of India. The time period is about 3 years from 2018 to 21. The authors is a mix of different people within the bureaucracy at different levels and of different expertise. So from the federal side, we have like the head of the department. I was the data scientist, GIS people. From the state, we have some representation from the provincial side and also the IT service provider. The program which we'll be talking about is PMGSY, which is about rural road construction, constructing roads in rural parts of India for helping them to go to school, hospitals, and markets. And it's a large program. It was launched in 2018, and it's a difficult selection problem. So the scheme was launched, like the government program was launched with a budget of 10 billion US dollars, which can roughly cover about 125,000 kilometers of road construction. But like the pool of rural roads in India is about 4 million kilometers. So we have a hard selection problem of 2-3% of the roads which we can pick and upgrade within the government program. But there's also a policy focus. It's not that all roads need to be upgraded. The roads which are in a bad condition and are helping people go to schools, hospitals, and market vaguely, that was the policy statement. Those were to be picked. And now roads is a very difficult selection problem. There are many competing demands, and there are a lot of vested interests involved in selection of roads. It's a very visible form of development in the global south, like if you're able to build a road. And so there are a lot of pulls and pressures on the selection process of which road will be selected. So that was the larger problem statement. How do we select roads for this government program? And these are the different stakes at which we are operating. And it's a national program which is rolled out across the country. Like, so all blocks, districts, the states are part of this government program which we are talking about. So at the scale level, it pans out the entire country. So to set context on what was it that we did for the new program, I have selected the selection process for the previous program, which acted as the baseline. So there was a smaller version of the government program launched years ago in 2014. And I've simplified to show like what was the process followed earlier, and then what were the problems and what changes did we do to it. So selection of which road will be done is done at the block level, which is like a small administrative unit. And we have about 6,000 blocks in India, 6,000, 7,000 blocks. And the first step is to do inventory, like how many roads are there, how many villages are there, how many facilities, school, hospitals, and markets are there, and just listing them down. That's the inventory stage. The second stage is candidate road identification. So you try to form certain routes out of these roads, and you probably found like 3-4 routes out of these 100 roads, and you make them participate in a competition. So you don't take every road, you form certain routes which you think are nice, and you make them participate in a competition for the candidate roads. And then the third stage is where the routes which you've identified go through a very simplistic scoring mechanism, which is basically the number of habitations, like number of villages exactly lying on the road or the schools, hospitals, and they get some points. And based on that, they come up with a utility value. And the road which has the highest utility value and is in a bad condition is the one which gets picked. So very briefly, this was the process which was adopted earlier to our intervention. There are many problems to it, but the first problem which I'll talk about is the second stage, that the decision that who will participate in this competition is largely left to the block officers. And what it means is that I can cherry pick. If I know who I'm going to I know the formula which with everyone is getting scored, I can cherry pick the participants in the competition to make sure any road which I want comes up on top, because the competition is only within the 3-4 roads which are selected. So you can sort of manipulate the process. And the other thing is that at the national level, we don't know which roads are important and like what is the road usage at the level of 4 million kilometers of roads. So we don't also have an independent oversight into which roads are important or not important. So the candidate road selection is largely left to bottom-up forces, which then have various levels of pressures which they have to manage. But also the utility value, like the formula which is scoring the roads, is not perfect either. And I'll give a quick example. So for example, if this is the stretch, this is a road, and I'm talking about the stretch between A to B, the utility value is based on the habitations or the villages which are directly on the road. So these two habitations and the school at B, right? But if and AB has a good score. But if I move move the village a little down, and I move the school a little bit up, the people using the stretch are still the same, but the utility value no longer is the same because they're far away. Now, there was a reason that this formula was used earlier because it's manually implementable. It's a very simple formula, right? And it's transparent. Anyone can double check what the score has come. So there's some transparency to it, and it can operate at scale. You don't really need to do any network algorithms or anything else. It's like something which you can calculate in an Excel sheet. So there are pros and cons to it, but this was the basic. But yeah, if you stretch it out, the score reduces. So the way we started first thinking was, can we replace utility value? Is there a way we could have a better way of selecting roads? And largely this is a network problem, right? And so we thought that if we cannot do an independent survey of all the roads, which are like 4 million kilometers of roads across the country, maybe we can simulate traffic. So we came up with a very simplistic model in which we said every village should be accessing schools, hospitals, and market. And in a rural setting where resources are less, they'll probably be accessing the nearest schools, hospitals, and markets. So for every village in the country, we found out which is the nearest schools and hospitals and markets. We draw on GIS, we find out the shortest route, and we do it and repeat it for all the habitations in the country. And then you sort of take that information to identify which segments of the road network are most used upon by people, irrespective of where they are. Like, they don't have to be on the road. And so like in the example on the right, you can figure out that R4, like the middle section, is what most people depend on. But it's not necessary that the villages are on R4 itself. So this is a simplistic algorithm which we came up with, which sort of simulates rural traffic and makes certain assumptions on the way rural traffic operates. And we implemented it at the block level because that's where the selection happens. And this is like a QGIS plugin, which is like an open source GIS software. And we implemented it in QGIS, it runs. And that was large part of our intervention. And we said, maybe this is a better way of selecting roads than the utility value, because by doing this, you can get at the segment level how many people depend on it, and then you can rank the segments based on that. And it creates like a user-friendly map at the end of it, which we thought the block engineer will use to identify which roads should be built and not built. So that was large part of the intervention. Earlier, we thought that we'll use this to replace utility value, but there are constraints, right? You don't want to disturb, especially something like roads, which is a very politically sensitive thing. There was a little bit of pushback saying, okay, we cannot replace like the main thing. Maybe you have some wiggle room to change things, but you can't change the main formula. Also, there are advantages to the formula, which I said is transparent, scalable, etc. And anyone can question like the formula out of it. So we decided, okay, fine, maybe we cannot contest the utility value, but maybe we can still operate on the fact that the competition in the candidate road is not fair. And is there a way we can actually use trace maps, like the rank from the algorithm, to actually improve the competition? So we decided to stick to this question instead of changing the scoring function itself. And so the small change which we did in the intervention across other things was that when the block engineer is supposed to identify roads in the candidate road pool, they can do whatever they want. They can take any road they want. They can take a road which goes to their own home, but they have to also consider the top ranking roads from the trace map algorithm in the competition. So we didn't change the scoring function, but we said that in the selection of people who you are making compete, like the roads which you're trying to compete, you have to add some which come from us. Like, so you can get others from your public representatives, from your field knowledge, but also add these few roads which come from the algorithm into the pool. And then whichever road wins in the utility value function in the existing one is the road which will get built. So largely, so earlier it was just this which decided the competition. We just made a small tweak that now the roads which came from our algorithm have to be part of the candidate road pool. And in this way, the system doesn't get disturbed much. They don't think their agency has been taken away. We're just saying that we're just adding a few more options to the selection of roads. So we made it compulsory to add the top 15 roads from every block. The guiding principle was to not override field knowledge or political representation. And we retained the existing utility value function. And so the results, and then I'll quickly go to the discussion. The results were that every 2 out of 3 roads which eventually did win the competition were recommended by the algorithm. Now, there could be an intersection that maybe they were also planning to recommend the same roads. Not everyone's like a bad actor on ground. But in in aggregation, 2 out of 3 roads were actually from the candidate road pool. And also nice and interestingly, 1 out of 3 which won the competition were not good in trace maps, right? So there were still roads which did better in utility value than the outcome which came out of the algorithm, because the algorithm in itself is not perfect, and I'll talk about it later. But another part of this discussion is the amount of work which went, right? So we had to go geotag. We need the location of the schools, hospitals, and markets. So we had to geotag about 770,000 schools, hospitals, and markets. 3 million kilometers of roads were digitized on GIS. 1 million habitations were digitized, and like 6,500 maps were created, like the trace maps, which is the output of the algorithm. The last part of the discussion is like the talk is not about that algorithm, because the algorithm itself is something which is simple. But what happens when you're trying to deploy something like this in a public sector setting? And how do the quirks of public sector, which are very specific to public sector, end up influencing the deliberation, design, and production of data science projects within the government? So one of the key themes when thinking about public sector data science projects is the human capacity. In like the public administration research or in public policy research, a large part of the work which we talk about is state capacity. Like, what is the capacity of the existing state officials to implement anything, right? And a large theme of Global South governments is that we have weak state capacity. There are bureaucracies which are overburdened, underpaid, and there are sanctioned positions which are kept vacant. So like the people which are existing in the government are largely always overworked. And that is what we are suggesting should be like the underlying theme whenever you're thinking about any kind of data science project, and how different layers of the bureaucracy are going to be impacted by an intervention like the one which we did. And so something which often happens is that and there's research which shows that the bureaucracy is overloaded and they're multitasking, and so they lose focus on their core activities. We suggest that when we're introducing algorithms, the fact that we are introducing algorithms and the amount of work which goes in preparing the data or preparing the intervention is so much at different levels of hierarchy that it starts impacting the core duties of the bureaucrats. And so you might be creating an algorithm to improve certain outcome, but the very fact that you introduced an algorithm probably already started adversely impacting the outcome which you cared about, because the bureaucracy is now busy in preparing the stage for the algorithm to function. And so in this case, it's possible that the algorithm even does not get deployed, but the damage is already done in the preparation, right? And so a few examples from our project is that the algorithm had to be deployed into an existing IT system, and there was a lot of preparatory work which needed to be done. So our IT teams, during the period in which we were deploying the algorithm, stopped focusing on managing any other module, because they were so busy trying to make sure that the algorithm works and to make sure that it's integrated properly with the IT system. They stopped maintaining all the other IT systems, and a lot of things on the ground started getting impacted because we stopped maintaining those bugs, etc. The other thing is that running algorithms requires structured data on all roads, facilities, etc. And it's possible that the block only had a target of like say 5 kilometers or 10 kilometers, like one road. But in preparation of that, the person has to spend months in collecting information on all roads and all hospitals and all markets. And it's possible that the outcome of the algorithm is something which was already known to the bureaucrat. And it was only one road and they could have come up with it anyway. But to run an algorithm at a network scale, you need data of all the rows, and it's a lot of preparatory cost which gets added to find an answer which probably the person already knew. And these are also the bureaucrats which are involved in day-to-day activities of maintaining the roads, etc. And so for a couple of months, they all sidelined those activities to only focus on the preparation of the algorithm, right? So this is a cost which was getting inflicted on the core functionality. So generally something which we propose and which we try to follow in all the other data science projects which we do within the government is to question whether the work is going to increase or decrease. And often the work might increase. And it's very important to disaggregate the work which is increasing in levels of hierarchy. Because a lot of times, if you're working with the government, you might be working with the top layer of it. You might be communicating with them, you might be doing work with them or doing collaborations with them, and you might pitch a project, right? It might reduce the work of the upper bureaucrats. Like in our case, it helps us. We just had to code the algorithm. But it might increase the work of the frontline engineers, like the lower street level bureaucrats. So whenever we are asking this question, whether work has been increased or decreased, disaggregated by the layers of hierarchy within the government, and also because of the positionality of the people working with the government, say either externally or in collaboration, very likely that you'll be talking to the upper level bureaucrats and not the street level bureaucrats. And so their viewpoint might not be communicated. So always do a cost benefit, and also whose benefit and whose cost is being added to the system. Yeah, and like, yeah, because of our positionality, like at the top might not factor the costs at the bottom. And so an algorithm, eventually when it gets deployed, can be fair, accountable, and responsible once deployed for the end user, but it can still be very problematic in the production of it at different levels. So it's not just the end user or like which is interacting with the algorithm where we need to ask questions, but also like in the production of it and the preparation of it. Another theme which we discovered was data inequities. Like the algorithm requires clean data, right? If you miss out a hospital or if you miss some part of the road network is missed, the output will be very different. And what we found out that certain state governments, they had poor data quality, and the algorithmic results which were coming out were poorer for them. And poorer data quality might also be linked to historical marginalization, or like the state does not have good contracting abilities or good ways to manage contracts or money, etc. So the state governments which are already not well off did not have good data, and hence the algorithm did not give them good results, and they will probably not end up getting good roads selected. So like that, it percolates. And so this is something which we need to make sure of, because governments are also not monolith. So like even the capacities will vary, and so will be the outcome of the algorithm. Participatory design, I think this is linked to it. Often what we think is the end user might not be the end user because they are so overburdened. So you might be creating a map and you'll think like the upper bureaucrat is going to look at it, but the bureaucrat is old, is probably very busy, is going to outsource it to like a junior engineer to look at it. And so while the senior person is supposed to decide which road will get built, the algorithm output has been looked by a junior engineer. So there's like a mismatch on who's deciding and who's seeing your suggestions. Also very quickly, it also realigns responsibilities by introducing QGIS and all of these fancy technologies, like the map moved upwards to the state headquarters, which was earlier made locally. And so also it starts impacting like the accuracy of the map, because now you're making it centrally versus local knowledge, which is bottom up. So whenever we're introducing new technology, to be also mindful of how it'll actively realign the responsibilities within the government. This is another learning which we had was we could have made the trace map into like a more interactive digital map, and we could have embedded more information in it, but we explicitly tried to use paper, because in public sector, paper holds value. Like old media technologies like paper have certain values in bureaucracy. So we decided that the map will be in paper. And we also explicitly added design elements like a place to sign on the map, which makes no sense to the output, but it adds to the legitimacy of the outcome of the algorithm. So we have to see how we can use old media technologies to make space for algorithmic outcomes, like bringing those outcomes to what's already being used and not necessarily go digital. In interest of time, I'll skip the other slide. One of the things which happens is that whenever we are doing even simplistic algorithms, there are many hidden parameters and choices. So right, when you're doing machine learning, yeah, there are like broader biases, etc. But also doing something as simple as like a Dijkstra algorithm, there are many abstractions which we are making, which could impact people which are already marginalized. And I'll give an example of this algorithm is also sort of biased towards the marginalized already. The algorithm operates at a block level. It's an hierarchical thinking. We were thinking like the planning is made at a block level, so the algorithm will happen at the block level. But you end up not identifying roads which are going across the boundary. Like a person who's using the road is not thinking in terms of block boundaries. That's the way the government operates. But the person might be going to a hospital which is just across the boundary. But because the algorithm operates with inputs within the block boundary, it punishes the roads which are intersecting the boundary. So there's a very nice way in which like the people which are already at the margins and the roads which are in the margins are getting doubly impacted because of choices we made while designing the algorithm. There are other assumptions which I made which are questionable. People prefer to go to their nearest facilities. Might be true for a lot of cases, but might just not be true, right? And even if you want to go to a nearest school or a hospital, you might not take the shortest path because some paths are not safe for women, for example, if they go through like a shady area or like a jungle. So there are a bunch of these assumptions which we're taking, which can also be questioned. Another big assumption we make is that habitations are points, because we're doing point-to-point distant calculation, and it holds true for a large number of villages. We're talking about small population, 300, 400 people living together. But also, India is a massive country. Like some parts of the country have villages which look like this. Now you can't treat them as points, right? And the decision of the point, where do you put the point, also impacts like where you'll get the road, right? And so now in linear settlements, where do you put the point? Now this happens in certain areas of the country, and it's yet to figure out or qualify what's like the bad impact on it, but it clearly impacts like the decision where you decide to have the start road or the end road. This one, yeah. But yeah, the larger conclusion being, yeah, like public sector has a lot of quirks which have been well studied by public policy, public administration studies, and we sort of have to work on how algorithms are intersecting with these quirks if we want to, because we care about algorithms in the public interest and they're being used in a lot of high stakes situations. So knowing how they get produced will help us better come up with strategies to mitigate the biases of these algorithms, which are increasingly used. Thanks. So if you have any questions. Do we take questions or?
We have time for one question.
All right. Also, I can take questions afterwards if anyone has.
Hi, that was a great talk. I found it really interesting. I just wanted to ask, from your perspective and from the government's perspective, like you mentioned this thing about a lot of labor and work going into preparation or getting data, etc., which might not lead to as many benefits in the short term, but it may lead to, like, if we have proper data, we might maintain it, and over time it will give benefits. So like, what's the mood around long-term benefits versus short-term benefits of datafication of these things?
I think you're right. I don't think it's black and white. I think for any decision which we are making about collecting data, we need to do the cost benefit analysis. But like for in this example, the data which we collected needs to be updated, like the schools, hospitals, and markets. But that's a lot of cost. So it ended up being like a one-time data collection. And so now we have to talk about whether this effort was important or not for a one-time data collection. And for our case, we think it was. But I think many factors will play into figuring out whether data should be collected or not collected. I don't think there's like a very blanket answer saying it shouldn't be collected, but like many factors. But we can talk more about it offline.
Thanks for that great talk. Next speaker.